Hello everyone, welcome to our presentation on extending context length for enhanced entity extraction in legal contracts. This is a research and development project carried out by our team, Lidurshan, Bhairavi and Sangaran under the supervision of Dr. Udiyasanga Tayasivam. Introduction. Legal contracts are formal agreements defining terms and obligations between parties. They vary in complexity from short agreements to lengthy multi-page documents. These documents contain key clauses which often involve obligations or risks that require careful review. Entities Entities includes general information like parties, terms and conditions, restrictive governance, intellectual property clauses, other legal clauses like dispute resolution methods and termination conditions. Why entity extraction? There are three reasons. One is automated contract review. It speeds up contract reviews by automating term extraction and analysis. Second one is uh, risk management. It identifies risk by pinpointing crucial obligation and clauses. Also, it avoids human errors by automating data extraction and compliance checks. The problem statement. Existing methods for entity extraction from legal contracts use encoder-based transformer models limited to 512 tokens, requiring the division of contracts into smaller chunks for processing. This often leads to a loss of contextual information, which can impair the model's ability to understand legal nuances. Increasing the context length could enhance performance by preserving more contextual details. Our motivation. We have two motivations. One is directly modifying the architecture to handle larger context length necessitates pre-training and larger amount of computational resources. Although there are sparse attention like mechanism which can mitigate computational complexity, maintaining the high accuracy in an attention-rich contextual legal text remain a challenging endeavor. Also, utilizing a lightweight model remains cost effective, minimizing both training and inference expenses, which is crucial for scalable real-world application. Our objective was to develop a model that process beyond 512 tokens and also evaluate the model's performance against current entity extraction method using the quad dataset and train a lightweight model to reduce computational cost while maintaining high performance, and also finally generalize the model to accurately extract entities across different type of legal contracts. Extending context window, we use two interpolation method to extend the context window. One is linear interpolation, which expands the position embeddings, calculate the new embeddings using the old embeddings by weighted average linear interpolation approach. The second one is cubic interpolation. This is employed to address the non-linearity inherent in the position embeddings. It provides a smooth and more flexible mapping by considering higher order relationships. So we implement the both linear and cubic interpolation, evaluate each method using the quad dataset, select the better performing one based on the evaluation, and integrate the selected method into the final model for entity extraction in legal contracts. Layer-wise attention window. Self-attention has a quadratic cost with respect to sequence length. When extending context, this becomes computationally expensive. Our solution is a layer-wise attention window. We configure early or later layers in the Roberta encoder to have local attention windows and the other layers to have full global attention, which reduces total computation while retaining contextual capacity. Data collection. We observed that some of the entities had a very few positive example in court, limiting the model accuracy. To address this, we annotated 100 additional contracts focusing on four key low resources entities. Those are change of control, uncapped liability, IP ownership assignment, joint IP ownership. This improves the data diversity and model robustness. The demonstration of our application based on the final model we have trained. Thank you.